So, we have been discussing about surface mining with excavation and loading in these unit operations. In the last class, we have discussed how the single bucket excavators are used, that is shovel we have discussed, and then we also started doing some calculations regarding the shovel productivity. Now, today we will be resuming and discussing a little bit more with the shovel, and then we will be discussing about dragline excavation. Now, you know that as you have seen in this figure, this is one of the Kalgoorlie's biggest mine there. How a pit has been developed here. This pit is developed by shovel and dumper operations. So, such an excavations to achieve. Now, where exactly we start? At the starting of the excavation at a site, what we have the forest lands, where there will be also some non forest land, there may be other land use land cover. We have got a coal seam, we have the other overlying strata, these are overburden, and then there may be some built up that natural attributes may be there, rivers and all other things. Now, when we start excavation in these sites, what happens here? There will be number of operations we will be doing in sequence, as we have said, that drilling and blasting, excavation and loading, dispatch. So, this ultimately we will be creating a void, that to get this material out, all the overburden from here we have taken it and put it in an external dump. Now, when the mine will be proceeding further, as you see here, when the mine has gone, then we have got certain space inside the pit, and then we start constructing the internal dump. Some of the overburden from here which will not go to this position, rather it will be coming as an internal dump. So, this material is stored over here. Now, this dump formation, that is the spoil dump or overburden dump or waste dump, that formation is it goes side by side, that is a dump management and its excavation, these are two simultaneous job. Now, we know that inside the pit, when these materials are kept, we will have to see that in future how this can be used and what will be the future situations here. Here this internal dump has come because this is the coal seam, but if there were another coal seam here, then the situation would have been different. Unless and until that seam is also excavated, we cannot use it over here. So, the condition, that is why we used to tell that geomining conditions in a particular situation which is possible, it may not be possible in other situations. So, you can see here, because we have got now limited space, because we have got a leasehold area only up to this much, we cannot go beyond. So, all our dump material will have to be kept over here. Now, while this operation is going on in these directions, we cannot keep the material anywhere here, but there is within a very less space we will have to keep the overburden dump. So, that while excavations we will have to see, we will have to keep our room for excavations will have to be created, and that we must see that the overburden dump kept over here does not create any problem for our day to day activities in the mines. So, there is also some environmental challenge here, because these are the loose material. When you are dumping it over here, due to rain and all, there may be some migration of the silt particles may be there to the river system. There will be the release of suspended particulate matter to the atmosphere, and we do not know if this material here something toxic, then they may create other health hazards. So, then also while dumping this loose material like this, then to maintain a stability of the slope is also a big challenge. So, like that we can see that how the excavation proceeds and the work goes. So, ultimately when there will be the mining is over, that is we may reach that ultimate pit configurations, that is we said earlier that there is a limit beyond which we cannot go, because now to get a single strip or a very low a single amount of increment of coal to be excavated, we will have to excavate a huge amount of overburden. So, at this stage the instantaneous stripping ratio goes very high. So, when the instantaneous stripping ratio is higher, it is no more economic or profitable to go mining beyond this depth. So, this is the ultimate pit limit or ultimate pit depth. Beyond that, whatever the coal is there, we will have to think of doing it by underground mining. So, this is the limit of doing our open cast mining. So, at this stage what is happening? Here we have a huge overburden dumps, and that are also put, if depending on this slope of this this floor, whether these are exactly it's stable to keep it over here, a lot of things need to be seen. And then these are loose, how much it can be compacted, and then what can be the alternative uses of this. These are also, this is a space art materials, these are resources. These resources will have to be used for the social benefits, and then that is the challenge or need to be done after the final stage is reached. That means, we will have to do a proper mine closure planning. Now, if we can do a proper mine closure planning, we can see we can keep a water body here. While keeping the water body, it can be reclaimed for maybe a sports center, or it may be a water reservoir, and the surrounding area where earlier there were forests, it has been returned to a forest land, and that our site is again remediated, and then it is the value additions have been taken place to the whole scenario. So, that means, while we are doing the excavations, we will have to keep in mind that we will have to do a planned mine closure. So, the excavation schemes which we will be doing in our mine, we must see that our post mining impact is reduced. So, for that, what we will have to do is, we will have to plan in which way we will start our excavation. Now, this as an excavation approach in general, in the last class I told you that when you are deploying the shovel, we can do a frontal cut or a drive by cut and parallel cut. Now, the frontal cut means that shovel is placed in front of the face. This is the original, this line, that crest line was originally like this. This was the bench or the face. In that, the shovel is standing just perpendicular to it, just it is facing the bench, and then the truck, it can come from this side and go in this way, or it can come from this side and go in this way. It can approach from both directions, and they can be spotted. That means, that shovel can spot it for loading either of the side. So, this is an arrangement in a frontal cut, where this swing angle, it may be, while you are cutting these ones, then the swing angle may be hardly 10 degree, but when it is cutting from here, the swing angle can go up to 110 degree either side. So, this is the way, that is, the shovel is excavating in a frontal cut by making a swing angle minimum 10 degree to maximum 110 degree and spotting the tracks, and this is the way we give the cut. Now, once this cut is complete, then the shovel will be moving to the next phase, next positions, and do the cut. And similarly, then later on the shovel can stand over here, cut these portions and give the bench the proper size. But while it is cutting over here, there will be some productivity will be less, because there will be less that is the size of that shape or available material will be less over here. But this is how exactly in the site you will be managing the operations. So, there is the other is a drive by cut. In the drive by cut, you can see here this dumper is coming. This is the first one, second one, third one by one it is coming. When this one was here, at that time this shovel is cutting these portions and loading it over there, and then this has the range from where that way the width of this width is being cut by the shovel standing over here, and this will make that your if you are sequencing properly, there will not be waiting time for the shovel and then the waiting time for the dumper, and the drive-by cart will give a higher productivity. So, one thing you can see here that in many surface mining operations you can find that while the shovel is operating in a position, that dumper comes and then they need to make a lot of movement. Whenever in your field visit you see that this dumper is making a lot of reverse movement and then taking long time over there, that means it is an inefficient operations. The surface is not properly designed, because the shovel's cycle time is hardly 32 to 35 seconds. Now, that if the dumper needs to do a lot of reversing, backing and then positioning at different places, it may sometimes take a time more than 1 minute. In that case, what happens, that time will be a waiting or idle time for the shovel. So, the time management in the phase is very important, and you need to see that. So, that is drive-by cart. You can have a parallel cart. The parallel cart is normally, you can see here two benches are there, one bench is here and another bench is being cut over here. These portions which you can see here, this is a berm which is given over here. Now, in this case the truck cannot come from this sides, normally the truck will be coming from this, because this is the operating width over here, bench width, where the truck movement is possible. So, this is here when you are locating the shovel and then loading the dumper over here, it is mandatory that we will have to have this truck will be coming and giving a positioning and giving a backward movement. So, that means there can be a single spotting, or if we are having a enough space, then we can make a double spotting. Normally, if the double spotting can be arranged, then the dumper's waiting time or the shovel's waiting time can be minimized. So, it is always better to use a double spotting arrangements in the phase, so that you can work with optimum utilization of your time. So, you know that this parallel cut is for expansion of the pit at the upper levels. So, one level, this is the lower level, here the bench is working. Now, in the upper level we are opening up another bench, it is we are expanding laterally, the horizontally the pit is moving, expanding. And then access for the truck is only from the rear side. You can see this is from this side only the truck is coming. Then truck stop, turn and back to loading positions. So, this is what is the operational arrangements will have to be made, that in this particular space we will have to make it properly level and prepared, so that there is no obstructions. Anytime if any stones or anything is rolling down from here, because ultimately these are all your blasted material. This blasted material may lead to some falling of the debris. There may be due to the shovel loading onto the dumper, there also some rocks and stones may be falling on this particular place. So, while operating this, we must have a standby auxiliary equipment like dozer will be here, which will be helping you to prepare this phase, so that the trouble-free operations of the dumper can be there and we can reduce the spotting and positioning time for the dumper. There could be single spotting or double spotting, as we are telling that this is a double spotting case and this is a single spotting case. Now, you have seen here that with a shovel, in the last class we told that this single bucket excavator, this shovel, particularly this power shovel, both hydraulic and your electric shovels are used. And then we now know that depending on the situations, we can select different types of shovel. Say for example, now if I ask you that if there is a water on the floor and that is a muddy floor, then which type of excavator you will be using. See here you can say that if you use a electric rope shovel, in that it will have to sit on the near to the toe of the bench. But you know hydraulic excavators in a backhoe mode, it can sit at the top of the bench and then it can collect the material from the reverse order. So, if your that is near to the toe, that floor of the bench, if it is wet and muddy and it is difficult to handle, if the situation like that will be is expected for several days in a year, then it is better do not go for excavation by this electric rope shovel, you use a hydraulic excavator in a backhoe mode. So, like that things you will have to find out. Now, coming to the drag line, this is also a single bucket excavator. You can remember from your earlier class that a drag line is a machine in which a drag line bucket is suspended with the help of ropes. There is a drag rope is there, there is a hoist rope is there, and then between these two rows this bucket is suspended in such a way that when this your hoist rope and drag rope hoist rope is released and drag rope is pulled, then this whole bucket will be coming and falling, digging into this is striking the face here, and then the material will be dragged and brought to it, and then when it is filled up, the bucket will be kept in a horizontal positions, the bottom will be there in a horizontal position, and then the boom will be swing down and the material will be discharged. So, this machine has got the capability that it can dig. So, if you are throwing the, that is giving a first pulling the bucket near to the boom, giving a hug, and then quickly releasing them as if throwing the bucket to a distance, and from there the bucket teeth will be dragging the material and we can create a trench like this. So, this machines you have studied, now we will study how this machine can be used for developing or excavating a pit. Here are certain things which are important. There is a what is the digging radius, and then up to maximum here it can, where you can throw it, that much is the maximum point from where we can do a cut over here. So, particularly while giving an initial box cut, we can have that is that it is the drag line is standing on the level of the material, and then it is making the box cut here. So, there is the machine is mounted on a tub, and then there is always a clearance will have to be kept from the edge to which it will be cutting. So, these are these dimensions, machine dimensions will be controlling how we will be getting the face. So, here normally this boom point sieve is there, you can have this 15 to 20 degree more than from here. So, the make the dimensions of the machines will vary, and then while developing our face we will have to select that machine, that which dimensions will be suitable for us. Now, this drag line in general it can also used underwater. This is say it is standing on the bank of a pond, and then the below here this is the bucket is released and it is dragging and then scraping out all the sludge over here, and then taking it along this up, and then it can swing it towards the side and it can dump the material over here. So, dragline can do underwater cutting is also. So, if we see here that dragline has got number of advantages. What? It has got advantages like we do not require any transporting machinery, because the overburden will be casted to the already excavated pit. So, that is why the elimination of the dumpers and that is your reduction of the diesel consumption is one of the biggest advantage of it. Moreover, it requires less maintenance, and as it does not have a fleet of trucks associated with it. So, the overall maintenance cost is also less. So, like that, if we see this machine, if it is properly deployed considering the geomining conditions, it could be useful. However, it cannot be used under certain conditions, because this machine is a huge machine. In your machinery class you might have studied it well, that it is a bucket capacity is 24 meter cube to your 30 meter cube buckets are used, and such a huge machines. And then when you are having a machine with a 96 meter boom, you will have to have a bench, optimum bench height can be about 20 to 25 meter. So, that means the operations must be a large scale operations, like your shovel can be used in your small scale operations. A mine with 1 million, 2 million ton production capacity with a stripping ratio 1.2 is very good for it. But dragline can handle huge quantity of material. As a result, where the stripping ratio is also very high, then to a certain depth it can negotiate, and this machine is useful there. However, so as a limitation wise, you can see that it is useful only for the large deposits and ensuring adequate strip length and sufficient reserve. It can easily operate on gently dipping deposit. For steeply dipping deposit, the spoil dump formation will be difficult because it may slip. So, this machine is not suitable for very steeply dipping deposit, because it casts the excavated overburden onto the that is available floor. So, when you are keeping this material, overburden material on an inclined surface, there may slip. So, that is why it will not be suggested to be used there. The machine can operate in places of simpler geology and gentle terrain conditions. Now, if there are lot of folding, lot of faulting, and then where the more machine movements required, there this machine will not work properly, or it will not give the proper productivity. The dragline faces with uniform overburden thickness along a strip gives better performance. So, this is what if there is a undulation, that is if the material below the overburden is that not having a proper thin demarcation line, then there can be a problem. So, when we use this dragline faces, normally we find that there is a, if there is a strip of, if we are having a coal here which is having a gentle slope or flat, and then we are having a overburden here of sufficient overburden bench height, then we can excavate by making the dragline to sit over here, and then this dragline bucket, it can throw the material, that is overburden will be, say if your overburden will be dumped over here. So, that is your floor is here, you can make your shovel and dumper to operate this particular coal seam, and then this overburden from here will be coming and getting deposited over here. So, that is your overburden. As this mine will be proceeding in these directions, that floor which is available, there the overburden is placed. So, this is this particular arrangements exactly make our this machine can best operate in places of simpler geology. That means, where that uniform phase of overburden thickness, then it gives a better results. To work with dragline in shallow deposits, the depth has bearing on the machine dimensions. As we said, this is, suppose you are having over here. Now, this particular block when mined, from here that shovel, the dragline is standing over here, and then this material when it will be dumped, it will be going like this. Now, below it, suppose this is our coal seam is here, this material it can maximum placed depending on if this is our boom length of the drag line, that will form over here. Now, if this height is more, if the depth is more, then this material which will be thrown over here, it will come and then it will place like this. So, we will not have enough room for working with the coal seam exposed. So, that is why there is a depth limitations. If it is a very that if the depth is more, at after certain depth we cannot, that is after certain bench height we cannot use the drag line because of the difficulty in dumping the material on the floor. So, there what is done, but thing is that that type of problem is not at all a problem, because what we can do is we can make a pre-benching. Suppose this is our seam exposed here, seam is here. If we find that this material, this one block size material can be easily dumped over here, and we can maintain a floor here to operate this coal seam, then we can use another machines over here, and then we can do a pre-benching, that is we are doing one bench cut, and this material by shovel and dumper we can dump it over here, and in that way we can make the systems to work. So, dragline faces, as we have seen in this figure, it can be an end face and a high cut or deep cut and a combination digging. So, what is here? What is the meaning of deep cut? That means the dragline is sitting at the top, that is you can see here, this is the slope, this is at a higher level and this is at a lower level. The dragline is sitting over here, you can see the cross sections for this particular face, and then the dragline bucket is dragging and the material from here, and then it is casting the material. Now, in a high cut you can see the dragline is here sitting near to the toe, this is the slope is going like this. So, you can have a dragline face, that is it is cutting, that is bucket is going pulled or dragging downward. Here the bucket is dragged upward. When a dragline bucket is dragged upward to excavate, it is called deep cut. When the dragline bucket is dragged downward to give a down cut, then it is called your high cut. This is the, and now sometimes a dragline may sit over here and this bench is being cut by high cut, and then this bench is cut by deep cut, and from the top this slice is being cut by your high cut. So, that means the dragline face can be a end face with deep cut or high cut or a combination of cut. Now, if you see here in a plan view, what happens in this particular case, the dragline is sitting over here, this is your coal bench, this is your overburden bench. Now, this is the cross sectional view along this. So, this dragline is excavating this material and then it is casting over here and it is forming a dump. That dump, exactly this is the angle of repose of the overburden material, and then there is one bench here, this is a coal bench which is being excavated just below here. So, the work will proceed in these directions. So, this is a very simple diagram for showing how a dragline excavation takes place. You can see here little bit detail of that. Here exactly the dragline, when it was at position 1 and standing over here, it will make a key cut here. Now, the key cut means the first cut which is given over here. You can see a slot is cut over here by the dragline is sitting on this, and then the bucket is placed over here near to the high wall of the previous cut, and then this portion is making a key cut. Then the dragline is moved to position 2, and from there it starts digging this one. The dragline boom can this give a swinging. So, it is just dragging the material from here, it is cutting. So, that the boom point it can reach up to here, means bucket will be thrown up to this end. So, you will have to see where the dragline will be positioned. It will be positioned in such a way that when the dragline bucket is thrown, that is released by the hoist rope, it will be touching at this toe of this blasted material. Mind that this is the blasted face on which the dragline is sitting, and this loose material it is collected by that. Now, the bucket will be collecting over here. When it is dragging the bucket and it is coming up to this, then the boom will be swinging, and then when it is swinging, it is coming up to here, the material will be released. So, this was already a triangular this cone or windrow was there of the previous cut. Now, this material is now thrown over released over here. It will fill some part of this earlier cut, and then this side it is going. So, you can see that there is this is one side slanting side, and this is another slanting side of the overburdens, which is being placed over here. Now, once it is cut like this, then what will happen? This will cut up to these portions, that is the whole block. This is the whole block will be now cut in this particular panel, and then this will be moving to position 3. When it will be coming to the position 3, by that time your second block is ready for excavations. It will give another slot cutting like this, and it will go. So, does it give you a picture exactly how the dragline is positions, and then it moves, and that during this movement you are exposing or you are getting the dragline face generated. Now, you can see here this is the floor, that is the pit floor, that is this was the overburden dump of the previous cut, and now this is your here already the coal has been excavated, and from the excavated coal we are getting this floor over here. So, if you see that same operations whatever we have seen in that cross sections, that means this goes as a block wise. This is a block 1, this is a block 2. Now, here that is when the block 1 has been removed, this much coal was exposed, and that is being mined by your shovel and dumper. It will be taking over there through it will travel to certain distance on the floor, then it can have a ramp on this overburden bench, and then it will be going to your stockyard. But for the overburden, what is there? When this block was there, that is, so one was earlier here. Now, that material has been dumped over here. As this is the bank material, blasted material, when it is becoming loose, then their angle of repose, depending on the angle of repose, they will form a panel over here. So, that means in a dimension wise, that is when this A block is removed, at that time your exactly A1 block of your coal is also getting removed, and there is a free space between the overburden dump and the coal seam. This is very, very essential to keep it. So, this thickness of the coal seam and that overburden height, this and this height of your waste dump, they have got the relationships. So, that dragline mining, whenever we design a face, this geometric relationship, how much material is going, and that exactly how it will be proceeding, whether this volume will be coming over here or it will be going and making a wedge over here, that will have to be very carefully seen. As I said, if the H is more, if H is instead of here, if it is coming up to here, then this material will be coming and touching this coal seam, and in that case, if this overburden dump buries these portions, then there will be a wedge loss, certain amount of coal cannot be excavated. So, then what to do? As we have said in this earlier also in this ones we said that whenever there is your overburden thickness is high, that is we cannot load it over here. Now, this situation comes sometimes when we are using a drag line on an inclined seam. If the seam is inclined like this, then what will happen? Initially up to certain height, if consider that this floor is sufficient, we can keep the dump material. Suppose we can keep the material here. Now, when it will be going after some distance, the dump will be forming like this. Then what is happening here? This depth is going on increasing. When this depth increases, then we cannot make the material, no longer we can keep it over here, because if we are doing a mining at this position, then this whole overburden it may touch over here. So, in such type of problem, how to solve it? One particular method is called your extended bench method. What is done in extended bench method? So, we can see here, because this is your seam, cold seam, and here it is the overburden. The overburden thickness is high. We have made here one pre-benching, but even in the pre-benching also, when you dump from here, this dragline is standing over here and it is dumping, then the material is touching over here. So, that extended bench method means we keep the loose material and then extend the bench up to here, so that now the dragline can sit over here, it can throw the material to a distance, so that it can come over here. If the dragline were not sitting here at this line, that this is your loose materials are filled over here to make a room for the dragline to sit. Now, the dragline throws the material up to this distance, so that by the angle of repose, whatever the material come, it does not ride onto this. If the dragline were sitting on that bench, which is our bench, then what would happen? For this, we would have dumped this point would have shifted to here. As a result, this line would have come up to here, that we would not have been able to excavate this much amount of coal. So, this is associated with certain degree of rehandling. This extended bench method, we have rehandled. We have taken some overburden over here and created a temporary bench or a bridge, and then on that bridge the dragline is sitting, and then we are doing it. Now, after that, after we excavate this material, we are putting this particular block material has come over here. Now, when we will make the next cut, we will excavate this material also, that extended, this is the extended bench, this material also will be coming over here. Then what we will do, we will make the dragline to move and keep some material to form again a extended bench, a bridge will be created, dragline will be brought over there, it will cut that block, and then again it will go, and this way the process will continue. Does it give you an idea about what is extended bench method? Now, when extended bench method is necessary, extended bench method is required where the overburden thickness is very high, and because of the limitation of the dumping radius of the dragline, we cannot throw the material to a distance from where it will not obstruct the exposed coal seam, or we can say that it is it will be coming onto that material. If the dragline reach or that boom is not very long, then whenever we will be dumping the material will be coming near to the bench on which the dragline is standing. So, that is why in the extended bench method, what is done? We rehandle certain amount of overburden to create a heap, or this bench is extended, so that where the dragline was sitting over here, now we have created another bench extended over here, made the dragline to sit over here, so that it can throw the material at a distance. When it will be throwing the material at a distance, from there, if the material by angle of repose when it is coming only up to the extended bench, but it is not going to the main bench. So, our coal excavation, or that is the exposed coal, can be easily handled by shovel and dumper. So, that is what, and that extended bench method has been used in our mines, in the northern coal fields mines. There this method is very popular because it has got an inclined seam, and that because of the inclined seam the overburden thickness has gone high, and then without extended bench method they cannot do. Other than the extended bench method, there are also using dragline in tandem, where the one dragline will be doing the rehandling operations only, creating, and then whatever the overburden will be coming and obstructing the bench, they will be removing by another dragline. So, like that the bench can be created with a separate tandem. So, dragline in tandem and dragline extended bench methods are used for negotiating, that is when the bench height is very comparatively bigger, that is for a given digging radius, given boom length, for a given boom length of the dragline, there is a limitation of the bench height. Now, to go beyond that bench height, we will have to design the excavation system, and one method is your extended bench method. Now, let us see a little bit more with this. What is that extended bench method? How do you do it? Now, suppose we are starting here. This was an extended bench of the made by the previous cut. So, what we will do this at the completion of the previous, the dragline is located at the end of the bridge. So, this is where the dragline is located. To start excavation of the new block, the dragline is walked off the bridge and placed in the line with the new positions here. This was the extended, or that is extended bench made of loose material. Here the dragline was sitting over here and excavating that whatever the overburden was there. This is now exposed coal. Now, this overburden which was there above this exposed coal were excavated by the dragline sitting on this extended bench, and the material has been dumped here. Now, to next job what it will do, the dragline will go and sit over here. After sitting at this position, it will give a key cut. Now, you can see here, to give a key cut, now it is sitting over here, and then it has started giving a key cut. A wedge will be formed over here. The dragline bucket will sketch this material, will be cutting, and then this key cut, whatever the material will be collected, this overburden removed, it is just forming one bridge here. So, you just see that this dragline, it cannot, if it is made that the material would have come over here. If it throw over here, then it will be giving an obstruction. So, purposefully what it has done, the dragline has made a key cut, the material available from the key cut has been used to make a new bridge or to extend this bench. This is the bench, dragline bench. So, your loose material is placed over here to make it extended bench here. So, at this situation, the key cut is completed. At the start of this cut, the dragline must be far enough along the cut. It is far enough, and why? It is to allow the bucket to be pulled right up to the length of the new block without the drag rope limit switches being activated. So, if we are going very near to this key cut, then exactly dragging limitations will be there, that is the drag rope cannot go beyond. So, that will be the limit of giving your key cut. As the cut is deepened, the machine works forward and across the cut to keep line with the high wall better at depths is taking. The key cut spoil is used to form the bulk of the next brace. So, you understood these things. That means, as you have seen in the previous one, dragline was here, that and your this was an intact overburden. Now, it has gone over here, the dragline has gone over here, and then with the dragline bucket it is giving the key cut, and that this material, that is the lower portions of this, has gone somewhere here, then this portion of material has come at the top of it, and we have got an extended bench. Now, after getting this, what it is done? Now, this extended bench is there, it will do some these portions of the material will be cut. The dragline can remove this high wall bench, that is, it can drag this material out and also put over here, and then it is the top portions of this material is also excavated from here. So, in what is in this particular situations, the new bridge is completed to the required length by part of the high wall bench and the top of the block. Same dragline position is used to excavate the high wall bench as well as the top of the block. Dozer is used to clean up loose bench material while the dragline is digging from the top of the block. Now, you can see here, when it is doing this cut, when you are making a high cut, there will be lot of debris and all will be falling. So, we will have to keep a dozer over here to keep these things properly. Now, this material has also this framed over here, you can see that which was the extended bench earlier, this is now getting cut, and this material, some of the material is getting placed over here. So, like that, after some time your new bridge is complete. When the new bridge is complete, then this dragline will move from here and come to the bridge locations. Now, you can see that it is coming near to the bridge, and from this position it will cut this material and started forming a new spoil dump. It was earlier spoil dump. Now, in this line, dragline is now dumping the material over here. That is, when it was sitting over here, it could not have come up to this. Now, this dragline has moved little bit towards this side, and then material is dumped over here. So, after that what happens? Now, the dragline is sitting on the new extended bench, and from there it is cutting whatever the block is there and also the previous extended bench positions. This portion is also being cut and thrown over here. So, the excavation with dragline to the edge of the working face, final cleanup of the top of coal seam is carried out at this stage. You can see here, now this coal seam is getting exposed. Earlier, as you see here, if we see here, our this was the line where dragline has gone here, this much is the overburden, below this overburden this coal seam is there. Now, as we go, we can see here that how this small coal is getting now exposed. You can see here this coal is getting exposed, your overburden is getting removed and overburden is getting dumped here, and then ultimately your coal is exposed. So, now your shovel and dumper will be placed over here, and then it will expose these things. So, this is the way you can get your ultimately that dragline will be cutting. So, we can see here that how the key cut is given, and then in a normal it will be going over here. If it was the bench height is not very high, in that case it can go on making this floor and then dumping it near to this, but if your this overburden thickness is high, then we will have to use this extended bench method. So, this you know about it, and this while you are using extended bench method, we can have the higher productivity of the shovel, will higher productivity of the dragline, and also we can negotiate to operate in a otherwise difficult to mine phases. So, what you can learn from here, that is the deployment of dragline in a particular site need to be seen that what is the geometry, and then depending on that your size of the machines, your ultimately the productivity will be affected. So, at this stage you can now start your self learning with calculation of the productivity, and also one advancement is in this direction is dragline is can be automated. That is because the whole operation is geometrically controlled, as these machines can be controlled with a robotic operations of the dragline is possible. So, there are a lot of advancement has taken place, and then dragline mining is an established methodology. So, you please make your group and then study in what are the factors that affect the productivity of dragline, and in which way that productivity of dragline can be enhanced. So, that is your work, and then till we meet next class. Thank you very much.